Hey guys, welcome to the last video of the basic Java series. Today we're going to be covering methods, overloading, and returns. And I'm sure you guys have been paying attention to all the other videos, but this one please try to pay specific attention to because it really segues nicely into object-oriented programming, which is what Mustafa is teaching right now. So if there's any time to pay attention, it's here. Of course, the last video as well, which also covered some very fundamental concepts. So yeah, let's dive right in. So what is a method? When I say, oh, write a method, or this is what I'm teaching you guys today, what does that even mean? So before we talk about what it literally is in Java, think about methods as functions or factories. They're factories because you can give them an input and they can give you an output. You can give them an input and they'll do something and they'll not give you an output. You can give them no input, but they'll give you an output. And you can give them no input and they'll give you nothing out, but they will still do something. Methods are a way of segmenting your code into smaller blocks that are reusable. Because think about it like this. Say you needed to calculate the smallest value in an array, like 50 times within the course of a program. Now you could write the code to calculate that because there's no inbuilt Java method to do it, right? See, that's where the methods come. There's no Java method already built into arrays to calculate the minimum, not that I know of. So what you would have to do is write your own method to calculate the minimum value in an array. Now the issue is that takes maybe 5 or 6 lines. You don't want to paste that 5 or 6 lines 50 times because then 5 or 6 turns into 250 to 300 lines, and you don't necessarily want that. So what you do instead is you would write a method that calculated the smallest value in an array given the array, and it'll spit it out back to you, and then you could use your method just like we used the string methods before. Remember, you have an object, you just call it, and then you pass in your parameters into the parentheses, and it'll spit something back out at you. If you need a refresher, go back to I believe it's modifiers and Boolean logic, so string stuff. I think it's, yeah, this one right here. And you can see I went over some string methods and I talked about how it takes in something and spits something out. So that's an example of a factory or method that will take in something and spit something else out. All right, so how do we actually go about creating a method? I'm going to talk about the main parts of a method in relation to a method that we all know very well, the main method. And if you forget exactly what that was, it is this part right here. It is what runs your code. Now the main method is a special method that Java looks for, and when it sees it in a program, it will attempt to execute whatever code is within the main method. But just distancing ourselves from the fact that Java considers it special, it's just like any other method in its structure. So let's go over the sections of a method, or the parts of a method. The very first word you are going to type in when you're creating a method is either the word public or private. Now, what this does is, as of right now, this won't have many applications, but later down the line, setting a method to either private or public lets other files in Java either access it or not access it. If I have a public method, just about anything in the same folder or even other folders can use that method, which is great and all, but if you want to develop tools that can be used and you don't want people to mess with your methods and use them because using them could break the program, you want to call it private. Calling a method private makes it so that only the class can use the method. And the class, if you remember, is this part right here. Obviously, there are certain ways around that, but that is object-oriented programming, and you don't have to deal with that right now. But Mustafa will teach you that. So for right now, private or public does not matter because you are working in one file, but just put public for now and you'll figure out when to use private later. The next word that you're going to type in is either the word static or you're not going to type in a word at all. I say non-static, but literally you just wouldn't put the word static there. As of right now, you always want to put the word static in there because a static method can be run in other static methods. And if you look at our main method, it's a static method. So you need to make your methods static to be able to run them within the main method, which is, for our purposes, what we're going to be doing. Again, there are ways around this, And if you know object-oriented programming, you'll know that what I'm saying is a pretty basic level, but then again, Mustafa will go pretty deep into how to manipulate that later on. But for now, just know that you want to name all your methods static. So the very first two words in our method are going to be public and static. For now, for us, that will not change. So you can always just type in public static and you'll have the first two words you needed to create a method. The next one is going to be something that you are going to change, and that is the return type. Now, if you think back to when I was talking about string methods, if you remember, I was talking about how it takes in something and spits something out. And what it spit out was always one thing. It spit out like an integer. Now, what that integer was, if it's like 9 billion or 200, whatever it was, that could change. But the fact that it was an integer never changed. So all those methods that you called that spit out integers had a return type of integer. What that basically says is, hey, when this factory, this method, is going to give output, it has to be of a type integer. Now, do I care what value that integer is? No. But I care that it's an integer. So you can use this not only for primitives, but for objects. Say you, for some reason, wanted a method that spit out scanners. You could make that. You would have the third word in your method be the word scanner. Remember, capitals do matter. So you'd have a capital S scanner, and you could have a method that spits out scanners. As in, when you call the method, you could set it equal to a scanner object, or you could use it like a scanner. Remember, if I believe I covered this earlier, but think of methods that have return types as if you were to highlight the method itself and replace it with a primitive or an object of that type, the code should still run. Say I have a string method that spits out an integer, I should be able to replace the method with just any number and the code should still run. That's just a quick way to check if you're using return types correctly. So for now, you're probably not going to use object returns for the methods we are going to be making, but it works just like a primitive return, which I'm going to teach you. Essentially, you just type in the name of your primitive, and if you don't want to return anything, because remember I said these factories can have no output, and this is where you declare what type the output is. If you don't want an output for your factory, aka method, then you want to replace the primitive that you are going to return back with the word void. And you'll notice our main method has the word void in it because our main method doesn't spit out anything. It is just run. It does something. This is a perfect example of a method that has an input, as we'll get into later, but no output. Because instead of an output, it's doing something that doesn't require a return. It just does something within the method. And that something could change the inner workings of like maybe some variables that we'll see later on. Like for example, you have a method that you give it something and it changes a variable, but there's no need to return it because it changes the variable within the little curly braces that denote what is inside the block of the method. So if that was a little confusing, I'm sorry, but essentially what I'm saying is void means this method returns nothing, but it doesn't mean it's useless. It can still do stuff within its code. It's like a little chunk of code allotted by the curly braces. And finally, we're going to talk about parameters. Oh, my bad. Before we talk about parameters, there's also, you have to name your method, which is what you're going to be typing in every time you call it. So you want to usually keep these names short and to the point. So use like abbreviations and stuff. Also use camel casing. I'm sure as you guys know, that's how most coders or programmers type camel casing. First letter is always lowercase. Every word after that, there's no spaces. Separating words, if there's like a compound word you want to use there, you just capitalize the first letter of the next word that's tacked onto the end. That's camel casing. So you want to name your methods something easy to remember and that gives you a hint as to what the method does. Because then as you're typing code and you're using these code blocks over and over again, you don't remember like, what did method 5 do again? Oh, and you have to go back down to it and then retranslate it for yourself. So you want to say method 5 spits out the smallest integer within an array. You'd name it min in r, something like that. And then you say, oh, min in r, that's what gives me the minimum value in an array. That's why you want to name your methods like that. And it can take basically any name except for certain methods that already exist. Like for example, main. I don't think you can name another method main. That would kind of confuse Java. Or maybe you can name it main as long as it doesn't have the exact same setup like public static void main string r. You can name it main, just make sure it's not the exact same thing as the main method, or you're going to create another main method. But name it whatever makes more sense to you. Finally, you have the input parameters. Now I'd say this is the most confusing part of the method because it's not just one thing, it can be like a lot of things. If you remember, I talked about how return types, you can only have one return type. However, you can have multiple inputs, so one output always, but can have 0 to infinity inputs. You can have, oops, didn't type 0 there. You can have as many inputs as you want for a factory or method. You can pass in 50 string arrays if you want. You can pass 100 integers if you really wanted to. You can pass in like a combination. You can pass in 3 strings, a character, an integer, a double, and a scanner for all you care. It can be any combination of any number of primitives or objects. And how you denote that is just like in our main method. Look here. This main method takes in an array of strings. And the name of that array of strings is args. Now, what does that mean? So when you call methods, if you remember, what we usually do is, let me type in here. We usually do is like, say, for example, like I have a string s equals my string, something along those lines. We would do s dot car, at 3, right? So right here, we see a method that takes in an int right here, right? That right there is the integer that we passed in. That integer doesn't have a name when we use the method, right? But if you were to take a look at the actual method itself, like within the base code for Java, you would see that it would have something along the lines of, I'm just gonna replace this for now. It would have something along the lines of int I, or something like that. Because what it does is it will take in an integer. And now when we pass in that integer into the method, we want to operate on it, right? But we passed in something that's nameless. We passed in a nameless integer, or it has the ability to be nameless. Because you could just pass in like a string I typed out. I could literally just type out a string when it's in quotes and just put it into a method and it should be able to take it. So how do we get around passing in something nameless, a value, into a method, but wanting to manipulate that value? Well, we give it a name when we declare the parameters for the method. So now, if I pass in a string array to the main method, within the main method, I can access the variable args. As you can see, my autocomplete is telling me, hey, args is a valid variable that exists, but it only exists within the main method. That variable, or the parameters that you declare, only stay alive within the method you create. So say you passed in 3 integers and a string, and you named A, B, C, and S. Within the method, within like the opening and closing brackets of the method, you could quite literally access, edit, add, do whatever you want to A, B, C, and S. However, you cannot access A, B, C, and S in their chain states anywhere else in the code unless you return it. So the inner workings of the factory, it's like a factory. By looking at the factory, you can't see what's happening inside. You can only see what's going in, and you can see and take out the result. So just like that, you have to name every single parameter that you pass in, or when you're creating a method, you have to name every single parameter, and then you can access them within the method. Say I wanted to take in this main method, it takes in a string array, but I also want to take in an integer array. Int array args2. So now within the main method, I can access args and args2 as valid variables, even though I didn't create them anywhere. Because when the main method is called, if I pass something in to main, string array args, int args, I will be able to access them within the method. But if I go down here past the closing bracket, it's not popping up in autocomplete again because it only lives within the method. And of course, there is the body of the method, which is completely up to you. You choose what goes in a method. No method is going to be the same. Like if you create a method, you're creating it for a purpose. You're creating it to fit something. It's like you're molding it around something to fit your purpose. Now, say you have like there's some algorithmical methods that do something for you, and there's just been a tried and tested the most fastest way, yeah, your code's going to look pretty similar, if not exactly similar to what's online. However, as you start to make your own projects, you'll see that, hey, I do this thing, this something in my code really often, and I find myself copy pasting that chunk of code over and over again. Let me turn it into a method, and then instead of copy pasting this 10 line block of code 50 times, I can quite literally just do a one-liner and get my result back instead of calculating it through typing out the calculation method every single time. The best way for me to explain that is this right here. I named it example 1. I know, bad naming, but this is what I would name it usually. This is an example of a method with an input and an output. So just by looking at this method right here, and by the way, I wouldn't recommend typing this out because you might mistype or something along those lines. So please go down to the GitHub and just copy paste these 4 methods because we're going to do a little bit of analysis on them. And this is going to be questions, so pay attention right now if you're zoning out. So looking at example 1 and the name it has, can you determine what this does? I'll give you guys a couple seconds. If you said this method sums up the values in the array, you would be correct. And as you can see, I have named this method sumAr. So now what I can do is this. I am going to make an integer array called unsummed or something like that, right? Equals, I'm going to give it 1, 5, 9, 2, 20, and 3. And say I edit this value later on, and I'll do like, unsummed 2, so I want to edit the number 9 in there, equals 50 or 30. And I say I do this like a bunch of times, and every single time I change it, I want to recalculate the sum of the numbers in the array. Now, this code right here, as you take a look, is how you get the sum of numbers in the array. You just do a for loop that iterates through it, add it to a sum, return that sum. You don't want to paste this 1, 2, 3, 4, 5-ish lines of code every single time you want to calculate the sum. So instead, what I can do is I can create an integer here, int return sum equals, and here's how it works. So watch this. Example 1, and just like a string method, I will pass in the array I want to sum up. In this case, I'm going to pass in unsummed. And just like that, returned sum will now hold the values of the sum of this array. And I was supposed to put this right here. And now I can paste this line after I edit the array. And let me just I can paste this after I edit the array, and I can just call example 1 again instead of having to repaste those 4 lines of code. So this is how methods can reduce redundancy in your code, because now you're not going to see the same like shape of code or the same lines over and over again. You're just going to see, example 1. And of course, example 1 is supposed to be named sumAr. I just called it example 1. But then you'll see, you can read your code out, like almost like English. The returned sum is equal to the sum of the unsummed array. And that was a lot. But essentially what I'm saying is methods help you reduce the amount of copy pasting you have to do. So now I'm going to just show you that it works. I'm going to sys out I'm going to just print A, and it's going to be return sum. And then I'm going to copy this and paste it here. So now we're going to print out the sum before changing that to 30, and I'm going to print out the sum after. And if I'm right, the sum should differ, the 2 return values should differ by 21. I'm going to run this. There we go. As you can see, it differs by 21, which means that this worked accurately. And this is the sum of the numbers in our array. Say you had you're making like a game inside Java, and you just needed to sum up like the value of all like the items in the player's inventory. You could write that, and instead of copy pasting it, you can just put it in a method and call that method. I'm going to clean this up a little bit so that you guys can just see a little more clearly. This kind of is the perfect example of like what to do per se. This is how you create an integer or an integer array to pass into a method. And of course, I am passing in an integer array because I said this method takes in an integer array. It could take in a string array, it could take in a double array, it could take in whatever, but you have to specify it here. And this is the thing about methods. You make them. This is kind of getting into more like I wouldn't say necessarily advanced, but more higher level thinking of Java, because now you have to decide, what am I making a method for? If you go too far, you're going to make a method that just runs your code for you. Might as well just put that in the main method. Do it too little, and you're making methods that basically do what methods in Java already do, with an extra thing that kind of helps your code. But then you're going to be calling so many of those that you might as well have just pasted the code over and over again, because instead of doing like, you've cut down your 5 lines to 4. Not that helpful, right? What you want to do is segment your code in such a way that you have to choose how to do this. Like, the person writing the code is the one that does the segmenting, and I can help you if you need some help with that logic. You need to choose what pieces in your code are being repeated a lot, and then you need to create methods that do those things for you efficiently and correctly. So that was example 1. And just take a look at these two, this bottom part and this, and just see how they connect for a little bit. And if you need help with this part, because I know like, oh, this is just it looks intimidating, I understand. But this right here is how you write a method. So let me go more into detail about how the method works, because I went over how to write basically a method up to like opening and closing brackets. And big thing I forgot to mention, notice how our main method's up here. Other methods go on the same level of the hierarchical tree as the main method, which means they don't actually exist within the main method. As you can see, this is the closing brace of my main method. My example 1 method is completely outside of that, and it has its own braces. So just remember that methods exist outside of the main method, but you call them within the main method because this is where your code gets run. So let's just step through example 1 step by step. I create an integer. Its sum is 0 because obviously the sum is always going to start at 0. I use a for loop to iterate through the array and add and set sum equal to the current value of sum plus the current value of the iteration of the array. So the very first run through, it's 0. And then I do 0 equals 0 plus 1. All right, so now sum is 1 and I is now 1 as well. So then I do 1 equals 1 plus ARR of 1. ARR of 1 is 5, because remember, we're accessing the first index, which is equal to 5 in this case. So now we're doing sum equals 1 plus 5. 1 plus 5 is 6. Not 6. Some number that is going to be determined equals 6 plus, what's the next one? 9. That is going to be 15. So now the sum is 15. 220, 235. Yeah. So on and so forth. So that is how this part works, which I'm sure you guys understand. But now this line right here, returning. So returning has to be done in the method if you have given it a return type. If you have given it void, you don't need to return something. As you can see in example 2, it doesn't have a return method. But if you give it a return type right here, which is what this is, remember, return type, you need to return something. And when I say you need to, the method always has to return something. If you use if checks, there's a possibility that a chunk of code might not execute. For example, if x is greater than 5, and then you'll like return x or something like that, right? But what if x isn't greater than 5? Java will give you an error and say, hey, there is a condition under which this code will not return anything. That's not right, because you need to have this code return its promised return type. So just be wary that when you're calling return, you need to have it be called on every possible instance or every possible runtime possibility of that method. Say if x is less than 5, this chunk of the code executes. X is greater than 5, this chunk executes. If it's over 100, this chunk executes. In each of those chunks within your method, you need to have a return value. Or you can put it at the very end outside of the if statements, because you don't care about returning different things for each scenario. Make sure if you see a red thing and says this does not return a value, but you're like, wait, my return statement is right there, you might have an if check in there that is throwing you a curveball. So just be wary of that. And as for the syntax of returning something, you just type in the word return and then type in what you want to return. That has to match up with the return type you specified when you created your method. Mouthful, but just rewind if you need to hear that again. So the next three methods, I want you guys to just pause the video after I'm done talking here and think to yourself what each method does. And try to like not write it out, but like type it out. This method does this, and just type it out like copy string does whatever. And don't just say copies the string. I know it copies the string, but say more detail what it does. I'll give you guys maybe a minute to do that. Just like pause it, try for like about a minute to figure out what each one of these things does. It's a good exercise, and then unpause the video when you're ready for me to just give a quick explanation. Did you pause it? Pause it. All right, good. Okay, so example 2. What example 2 does, which is called copy string, is you will give it a string and an integer. Notice how right here, this is one of those examples of me passing in 2 parameters. So if I was to call example 2, I'd pass in a string, Varun, and then I would give it a number, 77. So notice how in example 1, I had to set it equal to an integer, right? Like I said, oh, here's the value of example 1 that's returned equal to return sum. I don't have to do that here because example 2 has a void return type. It just does something, even if it's given values. So if I run this, it'll print Varun back to back 77 times. There we go. That's what example 2 does. It just takes a string and prints it out as many times as you specify. Example 3 is called populate random, which does what you think. It doesn't take in anything, as you can see. All I have to do is just say example 3. It doesn't take in anything, but I have to set it equal to an array of doubles. So I'm going to do double my equals new double, and as you can see down here, I create one of length 10, so I have to set it equal to something of the same length because you can't have like an array of 5 equal to an array of size 10. And then I just set myd equal to that, and then I can just do sysout arrays dot toString, and then I'll do. And then if you guys remember, arrays dot toString just lets you print out the array at hand. And there we go. 10 long array of doubles that are randomly generated. So that's what example 3 does, which is it populates an array of size 10 with random doubles. And what's nice about this is that you don't have to pass in anything. You just can call this whenever you say you repetitively need a set of doubles to like maybe calculate randomness or a dice roll. All you have to do is call example 3 or populate random. You don't need to re-type in this whole random r equals new random, create a new array, set it equal to, do a for loop. You just have to call example 3. It's like write once, use a lot of times. And finally, this is the weirdest example, but also possibly the most important to understand, when you have no input and no output. So this doesn't make the method useless. As you can see in here, I have this variable called changeable, but I didn't declare it in the parameters, so where did changeable come from? It's at the very top. It's actually a class variable. Now I have changeable right there. What I say throughout my code, I want to reassign that value, maybe for randomness, or it needs to be reassigned sometime during, I don't know, like say someone's playing a game on some game you made, and you need to reassign this value, but you don't want to keep returning it because it's a static value and it's a class variable at the very top, and you're accessing it absolutely everywhere. So you don't want to have to like call, oh, new random not next to every single time. Instead, what you do is you run a method called like random var, and what I can do is I will print out sysout changeable, and then I will call example 4. Oh, whoops, why did I get over there? I'm going to call example 4. Notice how I pass in nothing and I set it equal to nothing because it's a void return type and no parameters. But then if I just do sysout with the changeable again, you'll see first it'll print out 0 and then it'll print out something else. 0 and then some random number. That's how these methods can be used with no input, no output. They still do something. All right. So those were the main types of methods, the possibilities there, how to make them, what return types are, how to return. The very last concept is almost like a little taste of object-oriented programming. It is something called overloading. So what is overloading? Methods, as you can tell, they're very nice in that, oh, here's this block of code. It's like a stamp. Let me just do this again and again and again. But say you want to kind of change that stamp a little bit. Instead of doing the same thing over and over again, you want to, okay, I want to do the same thing, but I want to pass in something different this time. I want to do the same thing with the same input, but I want to get a different output this time. But you don't want to have 50 methods with like different names that you keep forgetting and they're like long names just so you remember what they do. You can actually name something. For example, I can copy paste example 1, word for word, paste it down here, and it'll give me an error. It says, oh wait, you can't have a duplicate name that has the exact same parameters. But say I change this int to a double. Say I change this integer array to a double array, and then of course just change this into just adapting it to be that way. And then I returned a double instead. So now I have another method called example1, but instead of taking in an integer array and spitting out an integer, it takes in a double array and spits out a double. So now but notice how this part up here didn't get messed up because my original example1 that takes in an integer and spits out an integer still exists. That's the power of overloading. Basically it says, oh, here is one name, but I'm going to overload it and give it a bunch of different characteristics. So now when I call example1, notice how there's 2 of them that appear, even though they're the same name. So I can have something that takes in doubles and something that takes in strings. This is powerful when you want to, like, you have to kind of set yourself up for success in this way. Say you know that you're going to be getting a bunch of arrays of different things, but you want a summation method for each of them. You would make example1, copy paste it, just change it a little bit, and then now you have all your sumR methods. They just take in different things and you can just call them sumR. And then when you're reading your code again, this is the thing that will really get you. As you become more and more of an advanced coder, you will start to forget what you made. You'll code something one day, and I'm a huge victim of this. Code something one day, you'll come back to it, you'll read it, and it's like, this is jargon, I have no idea what I'm doing. But if you name your methods correctly and you overload properly, you can just read your code like English. Like, hey, okay, so I don't really know what's going on over here, but I can tell that I'm passing in this variable and I need to sum it in some way, shape, or form. What is that? Oh, it's a double array. And it's an integer array down here. Oh, I remember, I was converting the doubles to integers, something like that. So if you name your methods properly, overload them properly, you're setting yourself up for success. So that's all for this video, and that's all for the basic Java series. I do not have questions out as of yet for methods, and I'm releasing this as we're getting into finals week, so please study for your finals. Don't worry about this code right now, all right? You can watch this after finals week. Just please make sure to really understand this because it is getting into object-oriented programming, and I just really want to make sure I'm handing you guys off to Mustafa on a good foot. I don't want you guys to be super confused about some basic concepts. As always, please reach out to me if you need help. I'm here for you guys always, even though I'm not teaching basic Java anymore. I'm still always here to help, whether it's with object-oriented or basic Java. If you feel more comfortable talking to me, or if you feel more comfortable talking to like Mustafa, Viv, or Zach, just please reach out to any of us. We're here to answer questions. We can even set up one-on-one sessions with you guys. We just want to make sure you guys are learning. That's our #1 goal. I'm gonna miss making these videos, to be honest, but I'll still, like I said, always be around to help. And here's the part that I know you guys have just been waiting to hear. There will be a final project that I cannot say require, but you really need to finish and send to me before I give the okay to Mustafa for him to start teaching you guys object-oriented programming. I don't know what this project is yet, I can guarantee you I'm going to send out a big message in the SpartaBot software channel saying, here is the final project for basic Java. Please make this. And as soon as you get it back to me and I make sure your code runs, boom, you are a basic Java graduate and you can go on to object-oriented programming. Keep an eye out for that. And when that project does come up, I will be available always for help. All right, and I will make sure I can even step through your code with you if you need help. Just want to make sure you guys can do that project before you move on to object-oriented programming. I'll also let you know when the problems for this set come out, although probably won't be anytime soon. Please make sure, if you were to pay attention to any videos, it would be the loops one and this one, because those two build off the other concepts, but then are, again, unique concepts of their own that are super important going to object-oriented. So that's everything. Love you guys. Thank you for sitting through these videos, and I will see you next time. Well, there's not a next time. See you in the software call.